Hey guys, so today I'm sorry I can't be with you, but we do need to start our proportion unit because of what happened on Friday. Things got a little bit weird, but we are going to take our inequality quiz on Thursday, but we do need to start our proportion unit so we don't get too far behind. So today we're going to do some basics of proportions, which hopefully you should have learned last year. We're just kind of reinforcing it and going over it before we move on to other things next class after our inequality quiz. So the first thing we're going to do is define some words, and so our first word here is a ratio, and a ratio is a relationship in quantity, amount, and size between two or more things. So for example, here we have teachers to students in the class. So if you're in my 5th period, our ratio would be 1 to 25. Okay, there's 1 teacher and 25 students. If you're in my 7th period, it's going to be 1 to 28, right? There's 1 teacher to 28 students. And the order that we write them in is very important. Teachers to students, they start with teachers, so we need to put the 1 on the top, and then the number of students in the bottom. A rate is very similar to a ratio. It's a ratio, so it is a ratio, but it's comparing two different quantities. So for a ratio, teachers and students, they're both humans. They're still the same units, okay? They're not comparing two different types of things. For a rate, it's got to be two different things. So 120 miles in 2 hours. Miles and hours are two different units. $15 for 2 pounds. We're comparing money to weight. Okay, so difference between a ratio and a rate is what are your units. If a ratio, if we're talking about the same two things being compared, and in a rate, it's two different types of things. A unit rate describes how many units of the first type of quantity correspond to 1 unit on the second type of quantity. So if our rate was $16 for 4 pounds, a unit rate would say it's $4 for 1 pound. So it's basically just taking a rate and changing it into, instead of non-simplified, you're basically simplifying it. So $4 for 1 pound. You always want the last unit to be a 1. And our proportion is our last vocabulary word. It's two ratios that are equal. So 1/2 equals 5/10. Okay, so it's just two fractions that are equal to one another. Okay, we can solve proportions for missing variables. That's going to be a big part of our unit, okay, especially with word problems. So to do this, we're going to use cross multiplication. Okay, hopefully you did cross multiplication in last year, and we're going to go over it very quickly, okay, but it's going to be really important. So our first example, we're doing x over 4 is equal to 5 over 10, and we want to know what x is equal. So cross multiplication basically says that you take the numerator of one side and multiply it with the denominator of the other, and the denominator of the other side and multiply it with the numerator of the other side. So you're multiplying across our fractions. So when we do that, 10 times x is 10x, and 4 times 5 is 20, right? So there's our two things, and we're going to set them equal to one another. So 10 times x, 10x, 4 times 5 is 20. But then we don't want to leave this here. We want to solve for x. So here we have a one-step equation, right? We just finished solving our inequalities and equations, so we want to get x by itself. To do that, we have to divide on both sides by 10, and we get x is equal to 2. Okay, so cross multiply, and then our last step is to divide. Okay, so we can do that no matter what our numbers are, even if they're decimals. So again, we're going to cross multiply, right? 10 times x is going to give us this 10x, right? And then on the other side, we're going to multiply 2.4 times 20, and we get 48. But then again, we want to get x by itself. So this is 10 times x. The opposite of multiplying is division. So we're going to divide by 10 on both sides. And when we do that, we get x is equal to 4.8, and that's our final answer. Okay, one more example. We're going to cross multiply 11.2 times x, and we're going to multiply 5.6 times 9. Okay, so 11.2 times x gives us 11.2x. 5.6 times 9 is 50.4, right? Then we divide on both sides by 11.2, and our final answer is 4.5. We can use calculators for this, so our decimals shouldn't bother us. We're just multiplying and then dividing. So 2 steps to solve our proportions. what we're really going to want to have to do is solve word problems using proportions. So word problems, we've been doing a lot of them on our TBTs, and a lot of the times we're setting up equations, but we can also use proportions to solve a lot of word problems. Usually if you're looking at a word problem, it's either going to be an equation or a proportion. So proportions are really important. So when we write our proportions to solve our word problems, the first thing I'm always going to want you to do is write a word ratio. Okay, and I'll explain what this is in a minute, but really you want to think about the two things that you're comparing and set up a word ratio to help you plug in your numbers. And I'll tell you exactly what that means in just a second. But then, of course, we're using proportions to solve, so you want to write your proportion. I want to see your full proportion. Where is your x? What are you cross multiplying? Okay, you're going to solve using your cross multiplication. Okay, and then our last step is to always label our units. Depending on our question, we might be talking about feet or inches or apples or boys or whatever. So we want to make sure we're labeling our units on our answer always. When you solve word problems using proportions, you need to use all of the steps that I'm about to show you. Okay, all of these steps to get full credit. You want a word ratio, proportion, show your cross multiplication, and label your units. Okay, let's get started. So our first question says the ratio of acid to water in a mixture is 3:7. The mixture contains 10.5 milliliters of water. How much acid does the mixture contain? So before I said our first steps are going to be to write a word ratio. So here is my word ratio, acid to water. Okay, when you write your word ratio, you're just trying to figure out what two things are you comparing. Here we have a mixture and these are the two parts of it, so those are the two things that we're comparing. Okay, then you want to think about how to fill in your proportion. Okay, I put acid on top, so I have 3 milliliters of acid, right? Acid was my first word here, it's my first number here. Okay, and water is our second and our second unit, right? So now I have 3:7 as my first fraction, right? 3 milliliters of acid, 7 milliliters of water. But the other thing that they told us is that we have 10 milliliters of water, right? So water, I put my water on the bottom, so I'm going to put my 10.5 on the bottom of my other side of my proportion, right? I want to make sure I'm setting up these words so that I'm putting my numbers in the right place, right? Acid to water, acid's on top, 3:7. Then again, they give us another measurement for water, 10.5, so I'm going to put that on the bottom with the rest of my water. Then my missing spot is going to be an x. When we're solving these proportions, you're always going to have 3 out of the 4 numbers, and then you're going to have to put a variable x in for the missing spot and cross multiply. Once you've set up your word ratio, it's very easy to solve. That's the hardest part, setting up your word ratio and putting your numbers in the right place, because then we're just cross multiplying and it gets really simple. Right? So when we cross multiply, you do 7 times x, just like we were doing before, and 10.5 times 3. So then let's look at that. So 7 times x is just 7x, 3 times 10.5 is 31.5. I didn't write my division on here because I just didn't want it to be too cluttered, but to get to our final step, this is multiplying by 7, so to get rid of that, we're going to divide by 7. When we divide by 7 on both sides, this cancels out, and 31.5 divided by 7 is 4.5. So my last step back here, right, we said we need to label our units. So here, I just don't want to end it at x equals 4.5. 4.5 what, right? What are we talking about in our word problem? Well, we were trying to find the missing part of our acid, and so our answer is 4.5 milliliters of acid. And we know it's milliliters because that's the units they're using for water, so we're going to keep it the same for acid. Okay, everything's in milliliters. Okay, let's try another one. So here we're looking at Mr. Hall, and he drove 168 miles and used 6 gallons of gasoline. At this rate, how many gallons of gas will Mr. Hall use for a 588-mile trip? So if we look, our two things that we're comparing are miles and gallons. So first we know it's 168 miles over 6 gallons, right? So we're going to put gallons in the bottom and miles on top. So look at my first fraction. That's what I did. 168 miles and 6 gallons on top. Okay, the other thing that they told us is that he needs to know how many gallons of gas he's going to use for a 588-mile trip. So since it's miles, right, we put our miles on the top, so I'm going to put miles on the top of my second fraction over here, right? And then x is on the bottom because we're trying to figure out what our gallons are going to be. They gave us both of our miles, and we're trying to figure out our gallons. Once you've set that up, now we're just going to cross multiply, right? So we'll do 6 times 588 and 168 times x, which gives us 168x. That's the easy side. 6 times 588, 3,528. Then we're going to divide on both sides. We're going to divide by 168 to get rid of that, and we get 21. But again, we want to say what our units are. So we were trying to find gallons, right? So it is 21 gallons of gas, or just 21 gallons. Use your word ratio to set up where your numbers should go and then cross multiply, right? It's easy to see here that we have miles for 6 gallons, those go together, but we want to know how many gallons it's going to be for a 588-mile trip. Okay, so use your words to help you fill in your numbers. Okay. Let's look at another one. These two questions are very, very similar. In fact, they only differ by one word. Okay, so the ratio of boys to girls in a science class is 2 to 3. That whole sentence is exactly the same. There are 15 girls in the class versus there are 15 students in the class. That one word is going to change our entire answer. So we want to be very careful when we solve these two problems. Okay, and I'll show you the difference. So here, this one's more straightforward, number 3. So we start off a little simple. The ratio of boys to girls in science class is 2 to 3. There are 15 girls in the class. How many students are boys? Okay, so here, we're looking at the ratio of boys to girls, right? So there's 2 boys to the 3 girls, and then it tells us there's 15 girls. So if we set up our word ratio, boys to girls is our word ratio, because those are the two things that we're comparing. We have 2 to 3, right? It's in the right order, boys to girls, 2 to 3. Just keep that order. And then 15 girls, so since that's girls, it's going to go on the bottom. Then this is actually a pretty simple one to cross multiply. You don't even really need a calculator. 3 times x is 3x. 2 times 15 is 30. Then to get x by itself, we're going to divide by 3 on both sides, and we get x is equal to 10. Again, we want to put our units on it, so we were solving for boys, so it's 10 boys. Okay, pretty simple, easy multiplication and division. Okay, boys to girls is our ratio. The difference between this one and number 4 is that students, if we set up the same ratio boys to girls, we couldn't put this number anywhere in there. The 15 students, we don't know how many of those are boys or how many of those are girls. So we can't set up the ratio boys to girls because we don't know how many of those 15s are boys or girls. So instead, what we're going to have to do is set up the ratio boys to students. Okay, because they told us that we want to know how many boys there are, so that has to be in our word ratio because that's what we're solving for. But the other thing we need, or that we have, is that we have 15 students. So let's see how we set this up. So I have 2 to 5 is equal to x over 15. Now some of you might be noticing there's no 5 in this problem, so how did I get my 5? Well, here they told us the ratio of boys to girls in science class is 2 to 3. So the easy part was the boys, right? There were 2 boys here. We want to figure out how many are in that class of 15 students. The kind of weird part is this 5. We have a 3 here, but this 3 goes with how many girls are in the class, right? But that's not what we're putting down here. We're putting students. If you think about this first ratio right here, what it's saying is that if you pulled 5 kids from the class just at random, you would have 2 boys for every 3 girls. So if you have a group of 5 students, 2 of them would be boys and 3 of them would be girls. So in that group, that small little group, you have 2 boys out of 5 total. So 5 students in that group. Okay, these two together, 2 and 3 make 5, right? So that's how we got our 5 down here. So we have 5 students out of that little group, and we want to know how many boys would there be out of the 15 total in the class. So again, pretty easy multiplication and division once you get started, but making sure that we're setting up the right ratio so that we can get the correct answer. Okay, so 2 times 15 and 5 times x is our multiplication. 5 times x is 5x. 2 times 15 is 30. Divide on both sides to get rid of that 5, and you get x is equal to 6. So again, we want to put our units. This time we're still looking for boys, so in this case we're going to have 6 boys. So see, our answers are very different, even though there was only one word that was different in the actual problem. Okay, all right. Next one, 15 liters is equal to approximately 4 gallons. Okay, so whenever I see units, those are going to be my two things that I'm comparing for my word ratio. So here I've got 4 gallons and 15 liters. Those are the two things I'm comparing. Approximately how many gallons are equal to 40 liters? Okay, so we got 2 sets of liters and 1 set of gallons there. Okay, so that's my word ratio, liters to gallons, right? So the first sentence tells us our first fraction, right? 15 liters is equal to 4 gallons. Okay, so there it is. 15 liters is 4 gallons. And then they want to know how many gallons are equal to 40 liters. So liters goes on top with our other liters, and then our x goes on bottom with the gallons. Then we're going to cross multiply. 15 times x is 15x. 4 times 40, sorry guys, 4 times 40 is 160. Then on both sides we're going to divide by 15, and we get x is equal to 10.6 repeating. Okay, sometimes when we solve this we're going to get decimals, that's okay. That's why we have calculators to help us. Okay, so it is 10.6 repeating, and if we're going to put units on that, it would be gallons because that's what we're looking for. Okay, I think the ones with units are probably the easiest because their word ratio is really obvious. There's nothing tricky about it, they're just showing you the two things that they want you to compare right away. Okay, you don't have to memorize any of these conversions. I know in 6th grade, for the 6th grade SOL, no matter when you took that, maybe it was 5th grade, maybe you skipped it, but the 6th grade SOL, they make you memorize some of the conversions. For 7th grade, you don't have to memorize any of them. They'll give you what things are equal to so that you can set up your ratio and compare. No memorization. Sometimes they're going to make you solve shadow problems. So shadow problems are actually on the SOL all the way up through geometry. So it's good to learn them now. They're not going to go away. You're going to see them over and over and over again. Okay, so when we set up a shadow problem, I always set it up the same way. And height might be a little confusing, but I always do height to shadow. So height is how tall the actual object is, whether it's a person, a building, a tree, whatever it may be. Okay, and then the shadow is talking about the shadow height. So the two things we're comparing are the height of the thing to the shadow of the thing. So first, we're looking at the person, and the two objects have their own fractions. So first, our person is 5 feet 6 inches tall and casts an 11-foot shadow. So here is my first fraction. Okay, 5 feet and 6 inches is actually 5.5 feet, right? 6 inches is half of a foot. So don't put 5.6 here. It's half of a foot, so it's 5.5. So this is our fraction for our person, right? They're 5.5 feet tall, that's their regular height, and their shadow was 11-foot shadow. In my second fraction, I'm going to make a whole fraction just for the bus. So the bus says, how long will the shadow of a 10-foot bus be? So the bus is actually 10 feet, right? We're trying to figure out how long its shadow is, so that's our fraction for our bus. Then we're just going to cross multiply. 5.5 times x is 5.5x. 10 times 11 is 110. Divide on both sides by 5.5, and we get x is equal to 20. And again, everything here was in feet, so then our answer is going to be in feet also. It is 20 feet for the shadow. Okay, we have two more examples. So for number 7, the length of a train car is 56 feet. If the model scale is 1/2 centimeter is equal to 4 feet, what is the length of the model train car? Okay, so here we're looking at the model compared to the real thing. So they're telling us that on the model, 1/2 centimeter is equal to 4 feet. So the two things that we're comparing are centimeters to feet here. Centimeters on our model and feet in real life. Okay, so we have 1/2 centimeter And then we know that that's equal to 4 feet, so that's going to be my first fraction. A half a centimeter is equal to 4 feet when we're comparing our scales. Okay, and then our other number they gave us was in feet. So we're going to put that on the bottom of our fraction here. So 56 feet goes on the bottom, and then we're going to cross multiply just like we've been doing for every single problem, right? So 4 times x is 4x. 1/2 times 56 gives us 28. Okay, then we're going to divide by 4 on both sides, and we get 7. And again, we want to put units, and we're looking for the centimeters that compare to the 56 feet, so it is 7 centimeters. One more where we're looking at a kind of a scale or a drawing of a classroom. So here the width of a classroom is 35 feet, okay, and then 1 inch represents 3 feet on our drawing. Okay, so you'll see these kind of representations on maps a lot, like in history, right? It tells you how big the thing is in real life. But on our drawing, 1 inch represents 3 feet. So two things we're comparing here, again, are inches and feet. And then they told us that 1 inch represents 3 feet, and we want to know how many inches would it be on the drawing if it's 35 feet at real life for the width of our classroom. So then we're going to cross multiply. 3 times x is 3x, 1 times 35 is 35. Divide by 3 on both sides, and we get 11.6 repeating. And again, we want to use our units, so we were looking for the inches compared to the real life feet, so it is 11.6 repeating inches. Okay, so we are done with the we try. There is a you try. There are 10 questions. You're going to get them checked, and then once you're done with that, you're going to move on to the clue for inequalities to review for our quiz. Okay, remember for homework tonight, you have a quiz review homework because our quiz is on Thursday. So please, please, please do our homework and get this checked before we move on. Thanks, guys.